Hello friends, welcome to my channel. Today I would be talking about AP series and GP series. So AP stands for arithmetic progression and GP stands for geometric progression. Let's see the definition first. Here you can see that arithmetic progression, we can tell arithmetic progression in short as AP. We can tell arithmetic progression in short AP. So first let's define arithmetic progression. A series of observation is said to be in AP if the consecutive values have a common difference. Okay, I repeat once again, a series of observation is said to be in AP if the consecutive values have a common difference. We can start with an example. Here we can see the first term of this series. You can see this is a series, right? 1, 2, 3, 4, 5 and so on. So this is a series of observation. And you can see the first term of this series starts with 1. So this is the first term, right? So what is the second term? The second term is 2, third term is 3, fourth term is 4 and so on, right? So we start with 1 and you can see that there is a common difference of 1, right? If you just subtract 2 from 1, we will get 1. Again, if we subtract 3 minus 2, here also we get a common difference of 1. Again, if we subtract 4 minus 3, and we would be getting a common difference of 1. So which means that a series of observation which have a common difference in between the consecutive values, we call that series to be an arithmetic progression. Okay? So in that way we can just represent algebraically this series in this form, right? First we start with the value a, this is the initial value. The second value will be added by the common difference d. Then this is the second term. For the third term, we will add second term plus the common difference d. So which is a plus d added with d. So which will give rise to a plus 2d. So what would be the next term? The next term would be the third term, this is the a plus 2d plus d again. So which will be a plus 3d and so on, right? So this is how the arithmetic progression goes. Now let's talk about the two important formulas of AP. First, if we take the algebraic representation of the AP series in this way a, then the next series would be a plus d, next term would be a plus d, the next term would be a plus 2d, another term would be a plus 3d and so on. So the initial value would be a, or the starting value, we can call it as starting value, and the common difference being d. So if the series goes in this way, then what would be the nth value or the nth term of this series? You can see that first term is a, the second term is a plus d. Now the first term can be written as a plus 1 minus 1d, which is basically a plus 0 into d, that is a, right? The second term, this is the first term. For the second term, we can write this as a plus 2 minus 1d, right? Because you can see this value is nothing but a plus d. Then what would be the third term then? The third term would be a plus 3 minus 1d, which is a plus 2d. So defining in this way, if we goes in this way, we can get the nth term as a plus n minus 1 into d. So this is how this formula actually works. Okay. Now if we want to calculate the sum up to the nth term, then what would be the formula? Okay. The formula would be, we can easily check that the formula would be given in this way. The formula is n by 2 times 2a plus n minus 1d. What is n? The term, up to that term we want to take the summation, right? This is the nth term and d is the common difference here, n is the up to that term we want to calculate that sum, and a is our initial or the starting value, right? So this is the formula of AP series. Now next jump into the next definition, which we call the geometric progression or GP in short. A series of observation is said to be in GP if the consecutive values have a common ratio. Now what is the common ratio? You can see from this example that the first term being 5, the second term being 10. So if you just divide 10 by 5, it will give rise to the value 2. Again, if I divide 20, that is the third term, by the second term, which will be 2. Similarly, if I divide the fourth term 40 by the third term 20, we will be getting 2. So here 2 is the common ratio. So the common ratio is basically the ratio in between the two consecutive terms. Okay? So this is how the common ratio is defined. So a series of observation which will have a common ratio between the consecutive values, we call that series in geometric progression. Okay? So in this way we can write down the common term or the algebraical representation of this series in this way. That is A, the first term being A, then we multiply with the common ratio and we will get AR. Again we multiply with the common ratio R, we will get AR square. Again we multiply with the common ratio, we will be getting AR cube. Okay? So this is how we can calculate or we can get the geometric series, geometric progression series. Okay? Similarly, as we have calculated the nth term in the arithmetic progression, we can easily calculate the nth term for the geometric progression also. Okay? Let us write down the algebraic representation of the series once again. So the series goes in this way: AR, A into R square, A into R cube, and so on. Okay? So first term again, first term here is A, right? The second term we would be getting just by multiplying by the common ratio, which is A times R. Again we would be getting multiplying by the next term, which is A into R square. So which will be the third term. So similarly, if it goes in this way, we will be getting the nth term as this: A into R into n minus 1, right? You can observe for the third term, the power here is 2, that is n minus 1, that is 3 minus 1. For the second term, the power here is 1, that is 2 minus 1. So the power will be 1 minus, 1 less of the term that we want to calculate here, right? The formula is pretty clear. So again, if we try to calculate the sum of that series up to the nth term, the formula is given in this way, that is A into 1 minus r to the power n divided by 1 minus r, right? So let us take one problem from both these two sets. Okay? The first problem is that the sum of the first n numbers, okay, sum of the first n natural numbers. Okay? How it goes? 1, 2, 3, 4, 5 and so on, right? So this is the series, right? The first, the common difference being 1, you can see that the common difference being 1, here also the common difference being 1. So this is the series, right? So the series starts with the number A, so the starting value is A. What is the common difference? The D here is also 1, right? Now we want to calculate the sum up to the n term. So we know the formula, right? Let us write down the formula first. The formula is Sn equals to 2A plus n minus 1 times D multiplied by n by 2. Okay? So let us keep n by 2 at the beginning. What is the value of A here? So value of the A is 1 here. So 2 into 1 plus n minus 1 times D. What is the value of D here? D is 1. So hence we get this number n by 2, 2 plus n minus 1, right? So which is nothing but n times n plus 1 by 2. Hence this is proved. You can see this is exactly matching with this RHS. So hence left hand side equals to right hand side and hence proved. So this is how we can calculate this. Okay. let's try to do one problem on GP series. Okay, first let's take one GP series which is already been taken in the example. Let's take that particular series only, 5, 10, 20, 40, 80 and so on, right. First you can see that the fifth term being 80, right, this is the fifth term. Now let's try to see whether we are getting the fifth term as 80 or not. If we take the particular formula that we have discussed, that Tn will nothing but a into r to the power n minus 1, right. So in this series the value of a is 5 because 5 is our starting value, and what would the common ratio r? The common ratio r is nothing but 10 by 5, which is 2, right. So let's try to see what would be the value of this Tn. Tn is 5, that is a times multiplied by r. R is 2 to the power n minus 1. So here n is fifth, right, because we want to find out the nth term, which is 80 here. So n here is 5, so which is 5 minus 1, which is 4. So 5 into 2 to the power 4, right. So which is 5 into 16, which is 80. You can see that these values are equal. So this is how we can calculate the nth value. Okay. Now if we want to find out the sum of the series up to the fifth term, how we can do that? Again we will be doing this calculation only, that Sn is a into 1 minus r to the power n divided by 1 minus r, okay, which is nothing but a is 5, 1 minus r here is 2 to the power n is 5, right. We want to find out up to this term, right. So this is up to fifth term. So here n is 5 minus 1 minus 2, okay. So the value would be 5 times 1 minus 2 to the power 5 is 32 minus 1, right. So which is 31 times 5 divided by 1, right. So the value would be 5 into 3 into 5 is 155. Now let's try to find out the sum. First 80 plus 40 is nothing but 120. We add another 20 here, we would be getting 140. If we get another 10 here, we would be getting 150. If we get another 5, we get 155. You can see this value is exactly matching. So this is how we can do this sort of problems, right. I guess we have understood the problem of AP and GP here. Okay. So if you have any problem, you can let me know in the comment section below. And one thing, I'll upload these lectures in my website. I'll give the link in the description section below. You can just click and see these whole lectures in my website. Thank you for your attention.